Hello everyone. Today we are going to solve the problem of integration for a round unit circle of the type. If we have a function like this and limit goes from 0 to 2 pi, that is a unit circle which is given here, then we can easily solve it by changing the term of theta into their x form. Then we can change the cos theta in their iota's form, and we know that z is equals to e to power I theta, and then we can put these value of z in this equation to get iota's form into z form, and this is equals to z. Then we can write e to power I theta is z, and if we change it like this, 1 upon z we can write is minus I theta. Then we can put this value like this. We differentiate it to get the value of d theta. The dz is equals to like this, and we know that e to power I theta is z. Then we can put this value and get the value of d theta. Then we put this value of d theta and cos theta in the functional equation in the integral. Then we get the integral like this. After solving, we have seen there after solving we get this. For solving, first we should solve the value of 2 by taking the whole root, whole LCM, and then we get 10 minus 3 into, we solve this bracket first, we get z square plus 1 upon z. It should be whole upon z. Okay, then we get this value, and again we take the LCM for the z value, we get this, and we get the whole upon z, and this z should be cancelled, and this 2 goes to upward and come into the numerators. Then we can take the value of I outside, and taking the minus sign common, then we can write this equation like this. So we get this equation, and by thus we should firstly get the root to find the poles of this equation. So we find the roots of this equation. These are the roots we get. So we put these roots in the integral, and thus the poles of the integral should be z equals to 3 and z equals to 1 by 3. By the circle, we have seen that z equals to 3 lies somewhere outside of the circle, but z equals to 1 upon 3 lies somewhere inside. So we have seen this, the singularity, only singularity which lies inside the circle is 1 upon 3. So we should only take the residue for 1 upon 3. By formula, we put this value, and then we put the function, that is, this is the function we have. So we put the value of function here, and after solving we get this. Okay, so then we put the value of 1 upon 3 in this equation, and then after solving we get the value of residue for 1 upon z equals to 1 upon 3 is this. Okay, now we, by the Cauchy residue theorem, we know that the integral should be written as 2 pi I into sum of the residues. As we know, there is only one residue we got, so we put this value in this equation, in this theorem, then we get the value of the integral.